Finding HCF and LCM using fundamental theorem of arithmetic. Now this theorem has a large number of practical application. The one which we look at is finding the HCF or the highest common factor and LCM the least common multiple using the fundamental theorem of arithmetic. This is a fairly simple task. Okay, let's say for example I give you two numbers 84 and 144 and I tell you to find out the HCF and LCM of these two numbers. So what you need to do is, as a first step, you just write down these composite numbers, okay, as a factor of their primes, right? So let's say for example 84 we need to write down, 144 we need to write down, right? So if I have to break down 84 into various prime numbers, what do? I will just first divide it by 7, I get 12, then by 3 I get 4, by 2 I get 2, by 2 I get 1. This you've been doing for ages, so I'm not getting into too many details around it, but I've just written 84 as 7 times 3 times 2 squared. Now please note that I could have written this as 2 into 2 also, right? But the way we write this for finding the HCF and LCM is that whatever is this prime number, we write down the power of that over here. Again, if I have to break down 144 as a product of its prime numbers, what do? Again, break it down. 2 times 72. Again by 2, you get 36. You divide 72 by 2. 36 by 2, I get 18. Again by 2, I get 9. Now by 3, I get 3. And by 3, I get 1. So I've got 3 squares and I've got 2 to the power 4. So I can write this down as 3 squares into 2 to the power 4. Please note I've written this just below actually the other number, because that helps you to kind of find out the HCF and LCM. We don't have any 7 in this, so I can just write this as 7 to the power 0. Here it is 1, here it is 1, right? Now in order to find out the HCF of two numbers 84 and 144, what I need to do is very simple. You need to find out for each of these prime numbers, okay, what is the lowest power. So let's say for example there are 3 prime numbers over here, 7, 3 and 2, right? We have to multiply this in such a manner that we pick up the power of each of these prime number which is the least, okay? Sounds strange. For the highest common factor you have to pick up the least of the power. So let's say for 7 it is 0 and 1. Obviously 0 is the lowest, so I put in 0. For 3, 1 is the lowest, so I put in 1 over here, right? And not 2. For 2, here the power is 2, here the power is 4, the least one is 2, so I just put in 2, right? And this gives me 7 to the power 0 is 1, 1 times 3, 3, into 2 to the power 2 is 4, 3 times 4 gives you 12. So the highest common factor of 84 and 144 is actually 12, right? When it comes to the least common multiple of 84 and 144, we again do the same thing. We first write down all the prime numbers, okay? Write them down as a product. Thus that, just that, we pick up the power which is the highest. So in 7 and 1, which is the highest one? It's 1. I put in 1 over here. For 3, 1 and 2 are the power which is more? Obviously 2. For 2, 2 and 4 are the power. Which one do I put? I put in the higher one. So this gives me 7 times 9 times 2 to the power 4 will give you 16, right? And the answer to this is 1008. So 1008 is the least common multiple of 84 and 144. Again, just to reiterate, if you have to find out the highest common factor of two numbers, what we do is, once we have put in the composite numbers as a product of their prime, we compare the respective powers of each of these prime numbers. Okay, we write each of the prime numbers 7, 3, 2, then pick up the least power between the two numbers. So 7, 0, 3, 1, 2 square. Whatever is the product, that's the highest common factor. For the least common multiple, we pick up the same procedure, just that the powers which are there are the ones which are the maximum. And therefore you get your highest common factor and least common multiple.